In the past, I've always asked you to memorize this. So in this video, we're going to understand why this is true. So if you look at this, if you have a over n, as n heads towards infinity, the limit of this will be e to the power of that very same a. So for example, if you look at this, if you have, let's say, 7 over n, as n heads towards infinity, the limit of this will be e to the power of 7. Or if you have 11 to the power 11 over n, and then as n heads towards infinity, the limit of this will be e to the power of 11. So if you have any constant over n as n heads towards infinity, then the limit of this whole thing here will be e to the power of that very same constant. So in this video, we're going to try and understand why this is true. So to understand why, have a look at your natural log graph. Your natural log graph looks like this. We know the derivative of this is 1 over x. So it's 1 over x. And then we would set up 2 points. So this would be x, this would be x plus h, and this is us using first principle. You should already recognize this. We would get the height, which is this thing here, divided by the across, which is the h. Take the limit as h tends to 0. So remember, visualize this as being 1 over h. So that would then give you this 1 over h here. And then remember, natural log of a minus natural log of b, that's the same as natural log of a over natural log of b. So here, this is one thing, take away another thing. So you can rewrite this as being your a here, and this is your b here, this is your b here. And then you can actually push this up here, so that would then give you this thing here. Because if I were to give you, let's say, natural log of a over b, then you can actually take this down here. So that would then be b natural log of a. Well, here we've got this thing here. We can push it back up here to give you this. So the point is that you're here at the moment. You're here at the moment. So you can push this back up here. That will then give you this. And then from here, exponentiate both sides. So e equally to both sides. That will then give you this. So e equally to both sides. That will then give you this. And then these two will, in a way, cancel each other out, giving you this. So now, if you look at this, hang on. So now we are currently here. So here you've got, looking at this fraction, break this up into 2 separate fractions. So here you've got 1, and then here you've got h over x, and then this stays the same, So now if you look at this, hang on, if you look at this is very similar to this. The difference is that here you've got 1 over h, here you've got n. Here you've got as h tends to 0, here you've got n tends to infinity. So the two are very similar, but here's the thing. Make this substitution. Let a be 1 over x, let n be 1 over h. So this thing here will then, well, you can put it into here, so that will then, this thing here will then be your n. And then if you look at this here, h tends to 0. But then when you make this substitution, as h tends to 0, as this h tends to 0, you can see 1 divided by something that's approaching 0, then this whole thing here will be very, very big. So it gives the effect that n is heading to, well, n will be bigger and bigger and bigger. So that's the same. It has the same effect. By you making this substitution, well, let's work in reverse. Looking at this here, as n heads towards infinity, h is actually h is actually heading towards 0. Hang on. So from here, times both sides by h. So that will give you nh equals 1. Divide both sides by n. So that will then give you this here. So if you make this substitution, look what happens. As n heads towards infinity, this thing here will head towards 0, meaning h will head towards 0. That's this h heading towards 0. So let's work from this perspective. As h heads towards 0, as h heads towards 0, sorry, hang on. As h heads towards 0, as h heads towards 0, 1 over something that's approaching 0 will be very, very big. So n is heading towards infinity. N is heading towards infinity. You see, when you make this substitution, these two work. These two really align with each other. So hang on, let's start again. So we are currently here. We want to get to here. This thing here is very similar to this. Make this substitution, a equals 1 over x, and then n equals 1 over h. So looking this, 1 over h, so we can put this n into here. That will then become this. And then looking at this as, so you've got h times 1 over x. So this, well, we can put the a into this block here. That would, and then put the, so here you've got your h. Well, don't forget h is times both sides by h equals 1, divide both sides by n. Don't forget h is this. H, don't forget, hang on, let me think, where am I? Oh yeah, h here. Don't forget h is 1 over n here. So we can put this into here. So this is your a. So this is your a. And then this h here is 1 over n. This h is times 1 over n, which is a, well, it gets multiplied to the top, a over n, which is this a over n here. Well, you probably have to think about it yourself. Well, if you make this substitution and this substitution, this whole thing here will become this. So we've shown that any constant here, as n heads towards infinity, it will be e to the power of that same constant. This thing here, think about it for yourself. Make this substitution, make this substitution. This turns out to be same, well, and then this a here, you put into here, that's this a here. Okay?